Hello everyone, welcome to Cracker channel. So in this video we'll be learning about basics of computer networking, and this playlist is going to be completely for the cyber security. So from this playlist you can learn from very basics to the advanced level, and if you have any query or the question then you can ask me in the comment section. So let's start with our topic. So the first is what? Computer networking. Okay. So we have to learn about what? First of all, we have to know about what is network, right? So first we need to know about what is network. So you might have seen or you might have heard that you will be having what? Friend network, right? So you will be having the friend network. It means nothing but what? In this friend network, you will be having two or more friend, right? So that you will be calling it as that is the friend network. If you are talking about the employee or if you are going to talk about the industry, so in the industry what you will be having, in industry you will be having the what? Employee, right? So there also what happens, so there will be the employee network. Fine, are you all getting right? So then now coming to this, why you will be making these networks, why you will be making network, tell me. So that you can easily what? You can easily share some information, like share what? Information. Another thing is what? You can share your what? Happiness, yes, ideas, right? Joy, or you can say that happiness, sorrow, right, and etc. So there can be the multiple things that you will be sharing in the same network. So I was talking about the same thing for the what friend network. Now, if you are talking about the industry means in industry, what you'll be having the employee network, right? So they all will be talking about some project, some other stuff, right? So now, if you are coming to the word computer network, fine. It means nothing. Here also, what will be? Here also you will be having the what? Two or more computers that will be connected what? Together, right? Two or more computers. Yes, two or more computer will be connected what? Together. Fine. Yes. Now you can just see the picture, right? From the image you can see a number of computers are being connected there, right? So that you will be calling it as what? Nothing but the computer network. Fine. And now if you are going to talk about, you can see the image also, right, from this. So it means nothing but here what? We are going to connect with the friend so that you will be sharing some of the information. Here it is the example of what? Employee. Okay. So you can say this is nothing but this is the example of the employee. So they will be sharing some project idea. They will be what? Enjoying their achievements. Fine. So now the thing is what? So network is nothing but what? You can say it is nothing more than two or more computers connected to each other so that they can exchange information such as email, message, or document, or even they can share resources such as what? Disk storage or printers. Fine. In most cases, what? This connection is made via what? Electrical cable that carry the information in the form of what? Electrical signals. But in some cases, the type of connection are used such as what? Fiber optic cables. Okay. And we can take that if let computers communicate at extremely high speed by using impulses of light at what? 10 GB per second. Okay. So what is that? That is nothing but 10 GB per second. Okay. So this what you can consider it as. This is nothing as the impulses of light. So from this we can easily conclude what? You can conclude that a computer network is nothing but it is the connection of two or more computers that are linked to each other in order to carry what? Some of the tasks such as what? Printing, okay, sharing data and exchange of what? Electronics media. Fine. So now coming to, so I had talked about what some of the examples also, right? So why you will be creating your friend so that you can share some of the information. So in the same way, what you can see, you can easily share information from where from one PC to another PC, okay? And you can easily share some of the information from one PC to another PC. You can create and store files, okay, onto from one or more PCs. And along with that, what you can do more thing, or you can say that you can easily access information from one PC to another PC. You can also, what you can do means, if you are having the computer network, then it helps to share the databases on different servers. And if you are going to share what the databases, right? So, so just assume on one system you are having what one PC here, fine, and another PC is here, right? Just assume, okay. So suppose now the capacity of this is what, just take 512 GB, okay, and this is also what 512 GB, fine. Now the things comes what, it is not necessary to store the same file, same data on the same what, same PC. Are you getting? Means on the both PC, it is not required. So if you are just storing here on this PC, then with the help of the computer network, what means if you have connected together, then you can easily do what? You can take the all information. Are you getting? So what you can do, you can easily take the information and you can send back to this another PC. It means what? This PC1 data can be as easily shared with what? PC2. Yes. So with the help of this, what happens? It also helps to minimize what? Cost, right? So that becomes the another advantage. Now, another thing is what you can see here, what connect input output devices also, right? So if you have connected on one system, if you have connected, if you want to connect input output devices to a computer, okay, so let's make it clear by taking one example. Fine. So let me clear. So just assume this is your what? One PC. Fine. Just I'm taking the two PC example. One PC. This is the first and this is the second PC1 and this is PC2. Fine. So here you will be having what? Some of the, okay. So let me make it big so it will be more. Okay. So now suppose what, you can easily connect input output devices. So here in this one PC, so in this one PC what, PC1 and this is the PC2, fine. Or I can take 1 and this is 2. Now here what you can see, if you are just keeping here what, one input device, okay, input device you have inserted in this PC1. And another thing what, just take the output example. For the output device, what you can take as the printer, right? Yes, fine. Here, if anything, if you want, if you have done on this one system, you can easily print out from another system also. Are you getting? With the help of what? This, the facility that it helps to connect the input output device together. Are you all getting? So now coming to this, now what is network topology? Okay. So first of all, before starting this, what we have to understand? We have to understand about topology. What is the meaning of topology? So just now we have talked about what? So about the network, right? Network means what? Nothing but two or more computers connected together, right? I'm making it short. So connected together. Fine. that you will be calling it as the network, right? And now the things comes what? So if you want to arrange, so there can be the n number of ways, right? Many ways. So there can be what? Many ways for connecting what? Two or more computer, right? So it means nothing but the arrangement of the network, which comprises of nodes and connecting lines via sender and receivers, is referred as nothing but the computer topology. So it means the arrangement of a network which comprises of nodes and connecting lines via sender and receiver is referred as what? Network topology. Okay. So now you can see here it is nothing but what? It is computer topology is nothing but it is the interconnection of various computer in a specific way. What you can say, it is nothing but interconnection of various computer in a specific way, which includes a connection between two computers using data cables. Two computers, you can see here, two computers we have used, so it can have two or more computers. And now the thing is what? The arrangement of a network which comprises of nodes and connecting lines via sender and receiver is referred as what? Network topology. And you might have heard about there are the different ways of what means you will be having. So you might have heard about lane. Okay. So there are different types of network, right? So first of all, before coming to this, we have to know about the different types of network also, right? For the computer network types. So what you can say, so types what? You might have heard about LAN, right? Local area network, wide area network, metropolitan area network. Fine. So, and so on. So, how they all are connected? Yes, because there is again what? Connection between two or more computer, right? So, on the basis of that only what? We'll be looking for the topology. So, there are various types of network topology which we'll be learning after just a couple of minutes. So, what are those? So, we'll be talking about mesh topology. So in mesh topology, what you can find, so you can see that you are having what? N number of computer connected together. So you can take it as, so I will be telling how to find how many number of cables are required. Okay. And another thing you can say that the term network topology also refer to the shape of how the computers and other network components are connected to each other. Fine. So you can say the network topology, it means it refers to the shape of how the computer and other networks components are connected to each other. So there are several different ways of network topology, each with advantage and disadvantage we'll be talking later. So just let's start exploring first type of topology, that is nothing but the mesh topology. So you can see in this mesh topology what you can find. So you are having what? So here every device. So you can consider it as, so this is nothing but device one. Fine. So here we have taken one, two, three, four, and five. Fine. So total how many number of devices we have? We are having five devices. So if you suppose there are n number of devices connected together with each other in the mesh topology, then the total number of dedicated links required to connect each other is an what? So how many number of dedicated links are required? So you can see here in this one system. So you can see this one system. Okay. So you can see here this first one system is connected with each and every. Can you see this? So let me make it more clear. So let me take that laser. Okay. So it will be more. So you can see this. Okay. So this system is having what? One. This first system is connected with one, then with two, three, then four and five. Are you getting? So if you are getting more confusion, what we can make it as. So let me write first it with 1, 2, 3, 4, and 5. Fine. So now here we can see. So 1 is connected with 5 also, 1 is connected with 2 also, 1 is connected with 3 also, 1 is connected with 4. In the same way, 2 is connected with 1, 2 is connected with 4, 2 is connected with 5, and 2 is connected with 3 also. Same way, 3 is connected 3, 2, 1, then 5, then 4. Are you getting? So this is the link for the 3. In the same way, for the 4 also, it is gets connected with each and every system. In short, what you can say, that there should be what? The connection between each and every, means one system should connect with each and every other system that are in the same network. Are you getting? So such type of network, what you will be calling it as? You will be calling it as mesh topology. So every device is connected with one another or a particular channel. So now you can see. So now how many number of channels or how many number of dedicated links are required? If you can see here, so first for this you are having, so so you can see for the one, it is having 1 to 5, right? So you can take it as 1, this is 2, so now 3, this is the 4, fine. For the computer one or system one. In the same way for the two, what? 1, 2, 3, 4 we have already taken. So this is already done, right? Here. So we'll be taking for the 5, it is what? You'll be taking it as 5. Fine. It is now 2 is connected with the 4. So this is 6. In the same way, 2 is connecting with the 3. Then 7. Fine. So 2 work is done. Now 3. So it is already done with the 1. So 7 with 2 already it is done. Now what we can find? You can see that this 3 is now connecting with the fourth system, right? So the total count was 7. So here we can make it as 8. Fine. So 3 is also connected. Now we are going to look for the fourth one. So here you can see for the third one, it has already made the connection. Now with the second system also, it has already made the connection. With one also, it has already made the connection. Now we can see it hasn't made the connection with the 5. So what is the here? The last count was 8. So we can make it as 9. Fine. So total number of dedicated links are how many? So you are having total links. Total links are how many? Total equal to 9. 5. Yes. But if you will look for the 5, then it is connected with 1 also. So for the second also, for the this, so it is connected with this 3 also, right? So here one thing we have missed, right? Sorry. So we haven't connected with the 3, right? So here only we forgot about this. So it should be 10. Fine. So total should be 9 plus 10. So we missed one. So we missed one. So it should be total equal to 10. Now you can see that it's an every connection is made. Fine. So what is the basic formula for this? So the basic formula for this is nothing but n into n minus 1 by 2. So how many number of total system you are having here? So total 5. Fine. So how many system you are having? 5, and 5 minus 1 equal to how many? 4. So 5 into 4 by 2 equal to how many? 10, right? So the dedicated links are how many? Total 10. So 10 cables are required. How many cables are required? Total cables required are equal to 10. Fine. So now we are going to talk about the mesh topology. So we have done for the mesh topology. Now we'll be talking about the star topology. So in the star topology, what you can see, so you will be having one system. Okay. So what you will be having? You will be having one system. Okay. And this one system is connected with what? with another system through what? Hub. So there is one common connection, common thing. What is that? You will be calling it as hub. Fine. So each and every thing is means each and every system gets connected with what? Hub only. Are you getting right? So in the start topology, all the devices are connected to a single hub through a cable. So you can see here also the cable is yes, for the this second system also, third system also, for the fourth system also. What is there? There is the cable, right? And now this hub is the central. So you can see this hub is nothing but hub is the central part. What it is? This hub is the central part, or you can say the central node, and all other nodes are connected to the central node. Yes, is it clear? Now, what we can conclude from this that here you will be having the two types of node. One is what? Passive or active. So the hub can be passive also. So you will be having what? You will be having two types of hub. So one is passive hub, or you can see it as active. Fine. So the hub can be passive in nature or intelligent hubs. That is an active. So active hub also what you can call it as? You can call it as intelligent hub. So don't get confused between. So what is the active hub and what is the intelligent hub? So both are same. Now, before coming to these things, what we have to know. So we should compare. So why we have came from this mesh topology to this star topology. So there might be some advantage and some disadvantage, right? So for this, we'll be talking few of the advantages. Okay. So the first advantage is what of this mesh topology that in n devices, or you can say if n devices are connected to each other in star topology, then the number of cable required to connect them is what? In the star topology. So I have not. So you can say what is the number of required cables equal to number of what? Systems, right? Or you can say number of computers. So how many number of computers is there? So one, two, three, and four, right? So total number of cable is one, two, three, and four. Fine. Now coming to the main advantage of this mesh topology. So what is the main advantage of mesh topology? That in the mesh topology, it is nothing but the robust topology. If a fault is diagnosed, it can be detected very easily. Yes, so suppose if there is any connection loss or if there is any fault in between what these two system. So you can take, so this was nothing but one, two, three, four, and this is your fifth system, right? So suppose if this particular connection gets failed, okay, these links get failed. So you can easily detect, right? Because it is connected means there is the connection with fifth system also, for the second also, for the third also, but it is not having with the fourth one, right? So you can easily debug that one. And data is reliable because data is transferred among the devices through dedicated channel or links and provided what it provides you the security and the privacy also. Okay, so you can we can talk it as advantage. So main advantage is what? It is nothing but robust. Okay, so easy to detect the fault. Yes. Now another thing what you can say, you are having means all the data is what? Data is nothing but it is reliable. Fine. Because data is transferred among the devices through dedicated channels or link only. And it provides what? provides what? Security. It provides you the security also, security and privacy. Means data security and data privacy are maintained in the mesh topology. But now what is the disadvantage? So you can see the number of cables required is what? N into n minus 1. It means, so let me write n into n minus 1 divided by 2. Fine. So what are the number of cables here required? So the number of cables required are 10. It means the cost of maintenance is what? High. And installation and configuration is very difficult. And for that reason, what? Cost of cables are also high as bulk wiring is required, hence suitable for less number of devices. So what we can write for this disadvantage? Okay. So the main is what? Maintenance. Maintenance is what? So maintenance is high because of the installation and the configuration. And cost of cables are also what? Cost of cables are also what? High. Yes. Now is there any doubt? No, right? So now we can see the advantage of this also. So start topology. So what happens? So you can just assume if this hub gets what? Failed. Okay. So if this particular thing is only not what, it is not able to operate, so the connection will be lost, right? So that is the main disadvantage of hub. So before coming to again the disadvantage, we'll be talking few of the advantages. Okay, so in this, what you can see the advantage. So if n number of devices are connected to each other in star topology, then the number of cables required to connect them is what? N only, right? So, it depends on the number of system. If you are connecting the n number of system, then the cable will be required what? N number only. So the cost is not high. And now you can see that from this figure, you can see that there are only four PC, right? So you can easily count the number of wires also, right? Or the cables that are connected with the central, that is hub. Okay. Now, so we have talked about the disadvantage that if suppose hub fails, now what will happen? The entire topology fails, right? And also the cost of installation is high because here you are going to make what? Hub. You will be using the hub in between. Now, and the major problem is that performance of this topology is entirely dependent upon the hub only, right? So if you are making any connection, so you should not totally depend on only one particular thing, right? So here in this star topology, you are directly what? Depending on the hub. So we can write here advantage. Okay. So advantage what first can be if n number of what? If n number of devices are there, then only n number of what? Cables are required. Fine. Now another what can be the advantage of this? S- So another advantage you can see that here there is, you can consider this hub as the what? Advantage also and the disadvantage also. So the main advantage is, means what? If you are going to consider hub only as the advantage means what? Here each and everything is getting what means it is totally getting its all system is having what only one connection, so it doesn't require n number of wires. Right. Now coming to another thing, that is what its main disadvantage. So what can be the disadvantage? So disadvantage is first, if hop fails, if hop fails, entire topology gets what? Failed. Yes. Now in the same way, the cost of installation is high because in between what you are going to use the hub. So the cost of installation is going to be high. And the major point, or you can say the major disadvantage, is that performing of this topology is entirely dependent upon the hub. So you can consider it as what? So second, we can consider it as the installation is high. What? Installation is high. Now, third one is what? Topology totally star topology. So don't forget to write star topology depends on totally depends on what? Hub. Yes. Now coming to the next topology, that is the ring topology. Okay. So in ring topology, what means one system gets connected with another, but that will be in the circle. It is in the form of what? You can easily see it is in the form of what? It is in the form of what? Ring, one after another, right? So in this topology, it forms a ring connecting devices with it exactly two neighboring devices. So if you will be looking, so this all one, just assume this is your first. Okay. So let me give the number. So let me give the clearly number. So it will be easy for us to talk on this. Three, four, five, six, seven. Okay. So in this figure, we are having how many number of system we have used here? So we have used total eight number of system. So you can see for the one, for the first, it is having the neighboring two and eight, right? So if you are talking about the seven also, it is having eight, six. So it means what? That this topology forms a ring connecting devices. So with its exactly what? Two neighboring devices. Now, what are the operations that will take place? So first of all, one station is known as monitor station. So just assume this it as what? So one system you will be calling it as what? Monitor, MON, sorry. So we can take it as monitor, okay, station. So you can consider any system as monitor station, but one system will be there that, or you can say one station, which will be known as the monitor station, which takes place all the responsibility to perform the operation to transmit the data. So data should be transmitted with uh, all the system that are what connected or that are in the same network, right? So for this what, this monitor station is only responsible to perform the operation to transmit the data. Now the station has to hold a token. After the transmission is done, the token is to be released for other station to use. Okay. So what it is telling, so this it trans first of all, this station has to hold a token. So it is going to hold what? One token. Just assume this is the your token. Okay. So this is your token. So it will go to its neighboring. Okay. So if the operation is done, means taking the data or transmitting the data. So what it happens now? This first one will release. Now it will go to second. Now it will go to third. Okay, then to the fourth, and it will go to so on. Okay. So it means what? This particular station is only responsible for what? To hold a token after the transmission is done. Okay. Now the token is to be released for other station to use. So after one, if its work is done, it will go to two, then it will go to three and four, five, six, seven, and again it will go to the monitor station and so on. Fine. Now the main thing is what? When no station is transmitting the data. Suppose if there is not any what station, suppose this neither one is what? It is transmitting the data. Okay. Now another thing is what? Neither two is also transmitting the data, and four, five, six, seven. These all systems. If they are not transmitting the data, then what? So then the token will be circulated in the ring only. What? It will circulate in the ring only. Are you getting? Now there are two types of token release techniques. So early token and the delay token. Right now we won't discuss more about that early token and delay token. Later on we'll be talking about the early token and delay token. So you can see here in the ring topology what there will be one station. So that particular station is responsible for transmitting the data and holding the token. Okay. Now that another thing is what if suppose if none of the station is what when no station or none of the station is what transmitting the data, then the token will be circulated in the ring only. Fine. So now we can go to our fourth topology, that is nothing but the bus topology. Okay. So bus topology is nothing, it is the network type in which every computers and network device is connected to a single cable. I think you all can see this first system, two, three, fine. Yes. So here what you can see, this all system gets connected with the single what? Single cable. Yes. So this bus topology is nothing but it is the network type in which every computers and network devices are connected to a single cable. It transmits the data from one end to another in a single direction. So it will only transmit from one in a one direction. It won't be having the bidirectional. Okay. So it transmits the data from one end to another end in a single direction. Now, if n devices are connected to each other in a bus topology, then the number of cables required to connect them is one, which is known as the backbone cable. So you can say, you can give the name it as what? Backbone cable also. What you can give? You can give it this cable name as the backbone cable because only one cable is responsible, right? For this, you can say it as the backbone cable. Now, you can see if the image that this bold blue line is nothing but the backbone cable and the red. So this blue line. Okay. So I'm talking about this blue. So this is nothing but the backbone cable. Now what about these cables? So this red. So red cable, what you will be calling it as? So this particular red, right? So these cables are nothing but these are the drop lines. Okay. What you will be calling it as? This line as drop lines. Fine. Now we can see there are the few disadvantages also. Suppose if the common cable fails, same as what our star topology, right? So if their hub fails, then again whole the what connection gets lost, right? Now in the same way, in the bus topology also, if this backbone cable only fails, then what happens? Then the whole system will crash down, right? And if the network traffic is heavy, it increases the collision in the network. And here comes the last topology. So last topology, what you can say it as hybrid topology. So I think it is clear So you can see it's in one by one. So mesh topology, okay, star topology, ring topology, bus topology, and hybrid topology. So this topology, nothing, it is nothing but your what? It is a ring, right? This is your nothing but your what? Star. And here this is nothing but your what? Bus, right? So you are going to create the hybrid topology. Okay. So in this, you will be using the three different what topology. So this topology is collection of two or more topology, which are described above. So now in this above, what you can see that, so this is in the ring topology. If you want, you can make it as the two also. But if you are going to make two or more what topology, then you will be calling it as what hybrid topology. So this is scalable topology which can be expanded easily. So if you want to increase, okay, or if you want to expand, then you can easily expand this hybrid topology. Now it is reliable one, but at the same time it is a costly topology also, because what you are going to do, you are going to use the different topology, right? For that purpose, what it becomes the costly also. Fine. So suppose just take the example here, okay? So in this, what this is your ring topology, right? So in this, what happens? So here you have connected what hub. In case if any of the system gets failed, or if the hub only gets failed, then it can get connected with other, right? So you can easily transmit this particular data information to this system, or it can take the information from here, it can circulate here, right? In the same way, you can see for the bus topology also, right? So in case, so in short, what you can say that it it helps to make the reliable, okay? So what it is going to make it as, it is going to make it as the reliable. Fine. So this is our last topology, that is our hybrid topology. Now, thank you. In the next video, we'll be talking about the different protocols and so on. Okay, thank you. If you have any question, then please comment down. Thank you.